In this lesson, we define the term electronics and identify some electronic components commonly used in automotive applications. Electronics is the science of controlling electrons. Many automotive applications use solid-state devices called control modules. Control modules use logic, and most have the ability to make decisions and set DTCs. Control modules need a good power and ground to function correctly. Be aware that many control modules have multiple power and ground circuits. Control modules receive inputs by monitoring the values from various sensors and switches. They process the input information to perform various types of output functions, such as activating a motor, light, or solenoid, controlling a display, or sending a message on a network. Each control module contains a central processing unit, or CPU. The CPU is a microprocessor and is considered the brain of the module because it makes all of the calculations and decisions. Every microprocessor uses memory to perform calculations and then make decisions required to operate the various electrical systems and components. There are two major categories for memory: volatile or non-volatile. Volatile memory is erased when the power is disconnected. A good example of volatile memory is a locked-up control module that resets after disconnecting the battery. The information that caused the module to lock up was stored on volatile memory. Since volatile memory erases when power is removed, the memory resets, and the module starts to work again. Non-volatile memory is not erased when the power is disconnected, so disconnecting the battery or unplugging the module will not erase the memory. Information like the module ID, vehicle identification number, and module flash software are stored in non-volatile memory. Each control module is equipped with three types of memory: ROM, RAM, and EEPROM. Read-only memory, or ROM, is hard-coded memory. The CPU can read ROM, but it cannot change or modify ROM. It's kind of like reading a library book. You can read it, but you can't change it. All ROM is non-volatile. Random access memory, or RAM, is memory that the CPU can read from and write to. RAM can be either volatile or non-volatile. Electronically erasable programmable read-only memory, or EEPROM, stores programs and calibrations that the CPU references. This is where module flashes are stored. EEPROM is also non-volatile. Control modules receive input information from various switches and sensors: throttle position sensors, or TPSs, accelerator pedal position, or APP sensors, manifold absolute pressure, or MAP sensors, and the AC pressure sensor are just a few examples of inputs used by a powertrain control module, or PCM. Input signals are either digital or analog. However, analog signals are converted into digital signals using an analog-to-digital, or A-to-D, converter inside the module. Control modules require accurate and reliable data from input devices to control outputs correctly. Since voltage in a vehicle is constantly fluctuating and voltage fluctuations could cause irrational input signals, most modules provide a regulated, filtered voltage for the input sensors. This module-provided voltage is called the reference voltage and is sometimes referred to as VREF. Most of the time, reference voltage is 5 volts. However, it can vary in some applications. The 5-volt module-supplied reference and signal circuits are designed to carry very small amounts of current. Never test these circuits with an incandescent test light. The current draw of an incandescent test light can exceed the limits of the control module and damage the unit. Always use a DMM when testing control module circuits. Reference voltage produced by the module is often used for multiple sensors and is typically a shared circuit within the module. This shared connection is not always obvious because the common connection is seldom shown on wiring diagrams. This means that if the VREF circuit is shorted to ground at one sensor, it can cause a loss of reference voltage for other sensors using the same internal supply.